Hey class, this is equations part 2. So we're going to look at finding the value of the variable in the equation, and today our focus is going to be using inverse operations to do that. So let's review what we did the other day with mental math. Was if we had the equation n plus 11 equals 15, we want to know what number plus 11 equals 15. And we used our mental math to say, well, we know that 4 plus 11 is 15, which means that n equals 4. 3y equals 15. This means 3 times what number equals 15? And we know that 3 times 5 equals 15, so our solution to this equation would be y equals 5. In the equation in C, you might not have seen yet. What this says, when you have x over 5 as a fraction, we have to remember that that fraction bar implies division. So translating this statement, it says, what number divided by 5 gives me 4? So you have to think of, whoops, I wrote the thinking one step ahead. You have to think of a bigger number, and dividing it by 5 gives me 4. So you might want to think, well, what is 4 times 5 using our extended facts? If I know 4 times 5 is 20, then I know that 20 divided by 5 is 4. And so then x equals 20. And using these extended facts are kind of what we're going to be doing today with our inverse operations. So just another review, the equation is a mathematical sentence with that equal sign. And the solution to an equation is what makes the equation true. So is in A, if our equation is 100 plus x equals 150, is x equals 30 a solution? And if we plug that in, 100 plus 30, is that equal to 150? We find that we get 130 equals to 150, which is not true. So that means that x equals 30 is not a solution. But how about 16 equals 20 minus a? Is a equals 4 a solution? Well, if 16 equals 20 minus a and a is 4, does 16 equal 20 minus 4? It does. So a equals 4 is the solution. The last one is 5p equals 150. That implies multiplication. So does 5 times 30, if p is 30, equal 150? And 5 times 30 is 150. So since we get 150 equals 150, that's a true statement that tells us that our solution is p equals 30. Translate this sentence into an equation. Jenny is 5 years older than her brother Mark. Okay, so if Jenny is 5 years older than her brother Mark, then Jenny's age, so if I use J for Jenny's age, and I use M for Mark's age, oops, age, don't need two A's, then Jenny is Mark's age plus 5 years because Jenny is older than Mark. Or you could say that Mark's age is, Mark is 5 years younger than Jenny. So if Jenny is 12, how old is Mark? So if Jenny is 12 and Mark is 5, and Jenny is 5 years older than Mark, you could do it two ways. You could say Jenny minus 5, so 12 minus 5, and that could give you Mark's age. We're figuring out this spot right here, and I know that 7 plus 5 is 12. That means that Mark must be, whoops, Mark is 7. All right, now we're going to start inverse operations. So just to begin with, the inverse of multiplication is division. So multiplication and division undo themselves. Like if you know that 3 times 4 equals 12, that means that 12 divided by 3 equals 4. Or 12 divided by 4 equals 3. So you can undo multiplication with division. And the inverse of addition is subtraction. You might be familiar with that, like checking your work. If you know that 10 minus 4 equals 6, then that means that 6 plus 4 equals 10. So they undo each other as well. So in solving equations, we're going to use inverses because we know that like the inverse of -4 is +4, the opposite. And when you add a -4 plus a +4, you get 0. And sometimes that's what we want. So in our first equation, if we're going to solve for m, whenever I'm solving an equation using my inverse operations, I put a line on my equal sign. This is going to help me keep my equation balanced. Whatever I do to the left side of my equation, then I have to do to the right side of the equation. That's kind of the rules to solving an equation. So you can change the equation, but whatever you do on this side, you have to do the same thing on this side. When we're solving an equation in math, our goal is to get the variable by itself. So I want to get the m by itself here. And so I have m minus 5. Notice the inverse of subtracting 5 is adding 5. So if I do that on the left, I can do that on the right as well. And then -5 plus 5 is 0. So if I have a -5 plus 5, I get a 0 here. So then all I'm left with is this m on the left. And this is my equals. And then don't forget to add on the right as well. 15 plus 5 is 20. So I get the answer of m minus 20. Or m equals 20. I can check that because it was, does 20 minus 5 equal 15? So plugging the m back in and just double checking that it works. And it does. So that is solving with inverse operations. I had a -5, and then to undo that, or to eliminate the -5 on one side, I added 5 to get m by itself. All right, so here I'm going to solve the equation y plus 2 equals 6. And I'm going to write my equation line. So I remember whatever I do on the left, I have to do on the right as well. Now, the inverse of addition is subtraction. So if I want to get y by itself, I can subtract 2 from both sides, because 2 minus 2 is 0. That leaves me with just a y on the left side, and 6 minus 2 is 4. So y equals 4 would be my solution. Plugging it back in, 4 plus 2 does equal 6. So check. Sometimes the equations are just written in a little bit different order. So here's an example of that. Instead of, y plus 2 or p plus 3, we have 3 plus p. Our goal still is to get the variable by itself. So we have a +3, and it's being added to a p. So these are two separate terms. And anytime you have two separate terms, you're going to use addition or subtraction to move that term to the other side, or to get rid of it on one side. Since it's a +3, the opposite of +3 would be to subtract 3. Whatever you do to the left, do that on the right as well. So 3 minus 3 here is 0. That leaves me with p on the left. And then 9 minus 3 is 6. So it should be, our solution should be at p equals 6. The value that's going to make this equation true is 3 plus 6 equal to 9. Just to double check. And it is. So that's using addition and subtraction as our inverse operations. The next thing we're going to look at is multiplication and division. One thing we have to remember is multiplication with reciprocals. The idea of the fractions, what do you have to multiply to a fraction to make it equal to 1? Because when we're solving for variables, we're looking for, what does x equal? Not what does, we have 3m equal 12. I want to know, what does 1m equal? And so to get a whole number or a fraction into equal to 1, you have to multiply by the reciprocal. So if I want to multiply 1/2 by something to equal 1, I would multiply 1/2 by 2 over 1. Because when you multiply 1/2 by 2 over 1, it equals 2 over 2, multiply straight across, and that simplifies to 1, and that's what we want. If you have a whole number like 3 times 1/3 will equal 1 then, because you can think of the whole number like 3 over 1. And then 3 over 1 times 1 over 3 would be 3 on top and 3 on bottom, and that reduces to 1. So that's going to be helpful when we're solving for our variables here. So our goal is to get down to just 1m. And so if I have a 3m, I'm going to multiply this 3, I'm going to think of it as 3 over 1, and I'm going to multiply it by its reciprocal, which is 1/3. make a little room here. And then don't forget, whatever you do on the left side, you have to do on the right side as well. So I'm going to take 12 over 1, and I'm going to multiply that by 1/3 as well. So on the left side, 1/3 times 3 over 1 is going to be 3 over 3m. And then on the right side, I'm going to get 12 times 1 is 12 over 1 times 3 is 3. And then I'm going to reduce this. 3 divided by 3 is just a 1m, and we typically just write that as m then. If it's a 1m, we don't need to write the m or the 1 in front. It's a implied coefficient. And then 12/3 reduces to 4. So in here, m equals 4. And I can go back to my original equation and double check. It was 3m equals 12. 3m means 3 times m, so is 3 times 4 equal to 12? It is, so that is our solution. All right, in the next one, remember that this means x divided by 3 equals 10. So what number divided by 3 equals 10? So I really have a divided by 3. The inverse operation of dividing by 3 is to multiply by 3. So if we're dividing by 3, we want to multiply by 3. Or you can think of it as the reciprocal. You have a 1/3 here. This is like a 1/3. And so the reciprocal is to multiply by 3 over 1. And you can make it all fractions if you'd like. Because then what happens is we're going to get a 3 times x on the top and a 3 times 1 on the bottom. So a 3x over 3. On the other side, we get 10 times 3 is 30 over 1 times 1 is 1. Then 3 divided by 3 simplifies to just a 1x. And then 30 divided by 1 is 30. So x equals 30. All right, a couple more practicing with the reciprocals. They're a little bit harder to catch on right away. So we have an 8 times g equals 16. So our inverse operation of multiplication is division. We were going to divide both sides of this equation by 8 because 8 divided by 8 is going to give me just a g. Then 16 divided by 8 is going to give me 2. The other way to think about that is with that reciprocal idea. It's the same thing though. You have 8 over 1, 16 over 1. So multiply by the reciprocal, which is 1 over 8, 1 over 8. Multiplying by the reciprocal will give me 1 times 8 is 8g. 8 times 1 is 8. And then over here you get 16 times 1 is 16. 1 times 8 is 8. And then reducing. 8 divided by 8 is 1. So 1g equals 16 divided by 8 is 2. So using that inverse operation of division and then reciprocals as well. Reciprocal idea is really nice for like using this last or doing this last example where you have 2/3 w equals 6. So in order to get w by itself, you're going to have to multiply both sides of the equation by the reciprocal of 2/3. The reciprocal of 2/3 would be 3 over 2, so flipping it. So then multiply the 6 by 3 over 2 as well. So on the left side, you have 3 times 2 is 6. On the bottom, you have 2 times 3 is 6w. On the right side, it's a whole number times a fraction, so I'm going to put the whole number over 1. And then it's 6 times 3 is 18. 1 times 2 is 2. So 6 divided by 6 on the left simplifies to 1, so we just get 1w. And then 18 divided by 2 simplifies to 9. So we have w equals 9. So I'm going to stop there for the video for today just to kind of keep it a little shorter. But we can do more examples of this in the next video or in class when I see you next. Thanks for watching.